Hey guys, what's up?
Hello.
Hi.
Hi.
Hey,
Nice to see you here. And I should mention nice background on the picture before after Leo. We have small talk
Well,
before our talk, and Leo told us that he is like some kind of guitar fan. Could you please?
I am.
Yeah. Could you please tell us a little bit more about your hobby? Because it's super interesting.
Yeah, I'm not a very well player, but I love the crafting of guitar. So I love building guitar. I have the actual space necessary um, to build a whole guitar from scratch, but I love getting all the parts and building guitars. This is a very nice hobby. It's a little bit expensive, but it's pretty fun. I love it.
Okay.
Um,
And let's go to our topic, to our main topic, because it's super interesting. What do you think about your auditory? Who is interested in your topic?
who is interested? I think web developers in general. I think that the goal for and the main takeaway from this presentation is to allow people to understand a little bit on how we actually understand and make some sense of ECMAScript, because we talk a lot about script here and there, and we talk a lot about the features. It's not the easiest thing to just jump into the ECMAScript and make some sense, especially for the syntax. So I'm going to try to help out with some baby steps to show what you can extract and have some understanding from it. People who are interested, who are already web practitioners or web developers, to make some sense and understand how ECMAScript works. And
Okay,
maybe they can even become a new contributor part of TC39 in the future. It would be great.
totally agree with you. Actually, we have some discussion. We had some discussion about it with Ujval. I helped him, but small, and I promised to help him again, but I have no time. I promise, Ujval, I will finish what I promised to you. And I think it's time to start our talk, our speech, our talk. Guys, are you ready?
just before we begin, I guess we could. So, since it's the first time Leo is getting introduced to our community, I guess we could warm them up by talking a little bit about Leo himself. So, Nicola, do you have any questions for Leo?
Yep. Yep. So I want to give some context about him. Well, I want to let him give some context about himself. So I want to ask what, like, you are part of the TC39 committee, and what do you do there?
All right. So um, I am I today represent my Salesforce team, the UI platform team from Salesforce at TC39. So that means I am a TC39 delegate. TC39 is a technical committee number 39. That's a technical committee from ECMA International, which is the organization that ships the ECMA standards. And by ECMAScript, I mean the core of JavaScript, the language that you know from the web, from Node.js, and everything. Everything is specified in there for the core of the language, the syntax, and the some part of the API that you have available is there. So I represent my team, and I'm also editor of ECMA 402, which is a specification, a small part of ECMAScript, which is the internationalization API. And I'm also a former maintainer of Test 262. I'm going to be talking about Test 262 here, which is a official test suite of conformance tests for ECMAScript.
Amazing. Yeah, just before we move on to the talk, one thing that you said really caught my attention when you mentioned that you uh, represent Salesforce at TC39. It's really interesting to me as a huge software company. How does exactly Salesforce contribute to TC39, and why do they? And perhaps why do you personally start contributing to TC39 in the first place?
Okay, so it's a set of two different stories, but they are all interesting. So I started. So I represent Salesforce because Salesforce used the web as a platform. If you do not know Salesforce yet, Salesforce is based on the web. The whole Salesforce application is a web application, and so we are heavy users of the web. We depend on the web going forward to make ourselves also like a better place. And this is interesting because we invest a lot on our software, and investing in our software means we need to invest in our platform. And one way to do that is making sure we can help to support the web moving forward, the open web. And we love that. We like to be part of this this ecosystem of the web where things are open, where we have a nice open source ecosystem available to everyone, not only for us. And I think we, as the same point that we are not implementers of web browsers, we like to provide some voice not only for Salesforce, but also like from our clients, from web developers that are working on the the Salesforce platform. And we use this voice to help shaping the web, new features and new technologies that will be available to everyone. And it's a pretty good and important part of that ecosystem where we not only use the voice of browser implementers, but we bring the whole web development community. And that doesn't mean like only bringing like big companies, but also like bringing a voice from each individual web developer. I think this is a pretty experience, and it's a pretty rich result that we have in JavaScript. My collaboration started because I'm formerly test framework maintainer. I came from the jQuery team, where I used to be the lead maintainer of QUnit, which is still very used today, and it's more than 10 years old now. But I have I have a lot of background with tests, and at some point in my life, even before working at Salesforce, I was given the chance and opportunity to test in ECMAScript itself through the project Test 262. So I've been called out to bring my experience with testing to the project, and I found myself writing a lot of, and through the test, I found a lot of inconsistency, not only within the test, but also in the specification and in the finding those inconsistencies. I didn't know where to go ahead. And I found myself going to TC39 to say, hey, I found this. What should we do? What should TC39 do? Since that moment, TC39 asked me to work through solutions and bring solutions that end up with me bringing things to the specification. And since that day, I'm attending the TC39 meetings and participating at TC39, trying to fix inconsistencies and everything. And that was so good. It was like coffee. I cannot get rid of it today. I love doing it, and it's pretty exciting. It's rewarding to the things that you do will affect the web in a positive way.
Oh, that's interesting. Well, yeah, it's really important that there are different point of view in the committee, I guess. So I just wanted to ask one last thing before starting, which is, do you have a personal favorite proposal?
I have some favorites. One of them is probably the current proposal that I'm championing right now. I am currently championing the Realms proposal. This is one of the most challenging proposals that I've seen at TC39 because that's a new thing, and at the same time, it's not so new. So in JavaScript, you have the concept, you have the already a specification for different realms. JavaScript is not multi-threaded language by itself, but you still have different contexts of execution. You can find today, like from iframes, and you have a different context as well when you use web worker. There's a different functionality. You can extract this context in other environments, like from Node. JS, you have a specific API. What we're trying to do is actually to expose this API to the web developer. And this is pretty much challenging. It looks simple because it already exists. It's more like exposing something that exists. But that brings so much of evolution to the web that we are facing some challenges to move this forward. I like the proposal not only because of the feature itself, but because the size of challenge it represents. Because it represents not only a thing that we need to work towards ECMAScript, but we need to work with other layering of the JavaScript ecosystem, and that I mean like integrating with HTML, make sure it works with browser implementers. This proposal specifically does have more layering challenges than any other regular proposal we currently have at TC39. And it's challenging, and I like the challenge. I'm pretty sure when it's done, it's going to be another rewarding moment of my career at TC39.
Realms is truly amazing, but it's technically cheating because you're the champion, so you couldn't have said that. But anyway, I think the producers are ready, so I would like to wish you the best of luck, Leo, and let's begin with the talk.
All right. Thank you. Just in case, I'm going to add 30 seconds of, you asked me my favorite proposal. You didn't ask me my favorite feature. My favorite feature is not a number. And I always tell that to some folks. I think not a number is such an amazing feature. It's not exactly an ECMAScript feature. It's like IE 754 is standard. But the fact that not a number is it's not a number, but it's still like a number notation for things that are not a number. They still have multiple numeric values underneath. So not a number can be represented by different bit notations, by different numbers. That thing goes like so long in interesting parts, and that's to little endianness and big endianness. That's so fun. And so nerd, as you can see, because I love it, but it's totally unnecessary complexity of explaining a single concept. I love it. All
Your
right, now that
definition of fun
I
is, yeah.
I like this in building guitars. I compensate that. So very much for having me here. I am pretty glad that I'm not talking into a like English as a first language audience, because I also don't have English as a first language. I'm originally from Brazil, from Rio de Janeiro, but now I'm based in the San Francisco Bay Area. But I'm pretty glad to be here, and I'm pretty glad to talking to this diversified audience that is completely new for me, and I'm so glad to be here. I'm gonna try. I'm not gonna try to extend it much, but it's possible. And that sounds like I'm trying to sound this as like it sounds like a poem to talk about everything that I'm gonna be talking here. As I mentioned, I love everything that I presented, and I hope you like this presentation as well, because it comes like out of my the love of the things that I do every day. And today I'm going to talk about comprehending standards notation for JavaScript. This is more like understanding ECMAScript. And once again, hi, I am Leo Balter. I am a standards engineer for the Y platform team at Salesforce. I'm also a TC39 delegate, as I mentioned. I'm the co-editor of ECMA 402, the Internationalization Specification API, and a former maintainer of Test 262. I'm going to talk about this project in this presentation. Also, my Twitter, GitHub, Telegram, I'm Leo Balter. I'm pretty happy to extend this conversation with all of you. Okay, so let's go to the next slide. You're going to see a lot of terms that I might be mentioning. So if you see ECMAScript, I'm talking about the specification of JavaScript itself. We do have TC39, which is a technical committee number 39. It's nothing else. It's just a technical committee of ECMA International that does the ECMAScript suite. And this specification is going to be used to build the core syntax and APIs for JavaScript. We have so many other standards, such as the HTML, CSS, and other web APIs. They're usually maintained by W3C and Webwig. They're not the scope of this presentation right now, because this one is going to be a little bit dense already. ECMAScript is a live specification. And by that, I mean, there's a lot of things coming in every year. You might have experienced the advent of ECMAScript 6 in 2010. That came shipped in with a lot of stuff, and it was a long time since we didn't have another edition of ECMAScript. But since then, we have yearly editions of ECMAScript. But most important, don't worry about that year editions. There are many things coming in every year now. We have still things like already shipped tenders. They're available today, even before the 2021 edition will be specified. We're going to be talking about some of them here. But one of the things that ECMAScript is not an API documentation for web developers. It's not really a useful source. If you are a web developer or web practitioner and you want to make sure like how something works, because for that you basically have MDN, and there's a lot of value in MDN because it actually is talking to the user of a feature. So when you go to MDN, you can you want to know like how a feature works. You have a glimpse of like how you let's say this function. How do you call this function and what to expect as a result, and the meaning of it. There's a lot of subjective, but it's still very important notation of what to expect from this feature, because that's also like user friendly. ECMAScript is not really that. And the problem with ECMAScript and why ECMAScript exists is similar to the expression we have in English, how to skin a cat. The same way you can ask, like, there are many ways to skin a cat. If you ask 10 developers how to implement a feature, you might find 10 different ways to code that feature. If I tell I want a function that receives this value, and I want if I receive those values, it needs to return that thing. It can be implemented in many different ways, in many different orders. The more complexity you add to the things underneath that function, more ways you have to implement that. Yeah, and there might even be a chance of a new framework is created in the meanwhile. Who doesn't like to see a new framework coming in every week? And we also do we also have ECMAScript because we want an interoperability. As I mentioned, there are many ways to implement things. But when we talk about ECMAScript, we talk about JavaScript. We need to make sure the same JavaScript that we use for what concerns to us as web developers is that like the same JavaScript we use is the same in every browser. It's not amazing to consider JavaScript in one browser as so different from a JavaScript in another browser. We do have experience with legacy browsers. I am from the era where it was so bad to get rid of Internet Explorer 6. I am happy that we are long past that era, but still, like interoperability is so important, and dealing with it is such a burden for web developers, and we need to remove that burden to the web developers and to the platform, bring as making JavaScript work seamlessly. So in order to provide that, we have ECMAScript being with this goal like of showing how things should run. And so ECMAScript really an API documentation for web practitioners, but ECMAScript is a document that provides rules and guidelines for implementations for those who are implementing JavaScript rather than using it. And that is made to allow any JavaScript engines, but also not limited to browsers, Node.js, to work seamlessly, at least in the JavaScript parts. And it's not unusual API documentation, as I mentioned, because it goes through each of the steps of a feature rather than saying like, hey, if you get this thing, you should return that thing. We're describing each step of a feature. And by each step, I mean, there is a lot of things to go in a very specific order. And that's one of the things that goes as a complexity for the specification, but it's rich in terms of making things working seamlessly in each browser without surprises to web developers. And for this presentation, I'm going to be splitting ECMAScript in two parts. Those are roughly two parts that compose ECMAScript, two of the main parts. And one of the part built-in APIs, I'm going to be talking about those first. And we also have the syntax, because you have methods and etc. They are specified, but you also need to specify the structure of the language, which is the syntax. What do I mean by built-in? As I mentioned, one of the examples we have prototype includes, we have this method includes, we have properties like the object prototype, we have mapped by with a number that I mentioned. For syntax, you have many other things as like how we define and how we do describe statements like if, else, while, how we describe variable declarations, class declarations. And it's even like rough to say, to put variable declarations, class declarations inside of statements, but this is a rough description of what we have on syntax. You're going to see this is much more well defined in ECMAScript. And also for expressions, you have like the method calls, because one thing is describing like what a method should do when it's called, but what actually defines to an implementation that the method be called. Also literal values, like you have specification for a string itself or a numeric literal as well, like 100, what 100 means to a language, what 100 should mean to a machine that will be reading that code. Okay, so let's start with how a built-in works. And this is one of the first pieces of this presentation that goes on a deep dive into ECMAScript. I'm going to start with a current proposal. This is array prototype.at. This is a simple method that's being added to the language right now. This is currently at the stage 3 of the TC39 process, which is the stage where we have implementations already shipping, ready to ship this feature, with the intention to ship this feature and make sure it works and it's compatible with the web. And it's important to know how it works, and but even how it should be working. Let me talk about how this feature works. As a user, if I have an array, if you want to access elements of an array, you have you can go with the square brackets and use an index to get things from an array position. If you get like with 0, you get the first item. We've got 3, you get the 4th item. There's a off by 1 here, which is a challenge for many people, but off by 1 is the career challenge for every web developer. The problem with this is not really by this off by 1 thing, but it's actually with the accessing things from right to left in array. You probably know the result of is accessing this with the -1 or the -1 here. It's going to be undefined. Actually, in order to get the last item of that array, you need to go through this expression. It's so frequently used, and it's frequently annoying as well. I don't love it. If you want to get the last item, you need to go access the length of that array and subtract by 1. Because the length of the array is 4, you don't have direct access to 3. So in order to always get the last item, especially because the array might be flexible, it might have a size, you need to go like to the length -1. That's annoying. So the .add proposal adds a method that goes as simple as for 0 and positive numbers, we'll basically get the correct indexed items, as just like the square brackets will do. But if you also have a negative number, you're going to read from the right to left. So finally a way to get things indexed from the right to left. It looks simple, and that's one of the reasons I'm actually showing this here. How do you actually implement that? If I ask you to implement that, you probably have a different idea from one of your colleagues. If I ask 10 developers to develop this, I'm pretty sure there is a very likely chance I'm going to have so many different implementations for a very simple method. That's something that looks simple as a concept, but there are many ways to do that. There is a multitude of implementations, and they might be correct. I'm not saying like they're going to be wrong. I am saying like the correct implementations might be different. By the way, the name of the proposal is the relative indexing method, because it does not only apply to array, but also to typed arrays and string. So here I'm going to give you a description of what we have today in the proposed specification for array prototype. And this is the actual specification. don't try to make sense of it, right? Because there is a lot of ECMAScript jargon and functionality. This is also a pseudo language of ECMAScript. That's not a valid language as a programming language. This is something that is set as a conventionally at ECMAScript. But in order to make some understanding of that, that's what I'm going to try here. I'm going to try to create a story. Let's try to verify points of that specific. Let's see how those steps go. I mean here is like if I call this function, I should run through all of those steps from 1 to the maybe until 7. And so here's my story. If I have an array and I have .at with the index 0, what should I expect as a return? And forget about the concept of this feature, but let's check this out with the current, with the current spec text. So as I mentioned, I have in my use case, I'm given a argument 0. So index is one of the first values that I need to figure out here. So I know the index is going to be 0. Okay, so I'm trying to make annotations of it. The this here, there is a description in ECMAScript for what this value is, and the this value here is just gonna jump a lot of going so deep in the specs. But the this value is what you have before the .at, and for that is my array with the strings A, B, C, and D. And then we have a to object. What is this? So in ECMAScript, as so many things repeat for specification, we also have so many abstractions. As you have in a web application, you can have, if you find things are repeating themselves a lot, you can have abstractions in order to repeat those steps in many ways. So to object will be an abstraction that will basically say a set of different rules, but it says if the type of argument is object, in my case, the type of this value is an object. This array that I'm giving here is an object. Turn the argument. It doesn't do anything else because to object ideally just coerces a value to an object value. And this already have my array, and I don't need to do anything with it, just return this array. So to object here will return array, but there is a question mark here. What is this question mark doing? This question mark is fun. There is also a thing saying in to object, if the type of the argument is new or undefined, basically you can extract that from this code here. Like let's say if you change the this value to, or and then to object could throw a type error exception. The question mark is basically another frequently used abstraction in JavaScript, in the ECMAScript code. There is a definition for what the question mark means, and it says if you have an exception, which ECMAScript will call it an abrupt completion. If you have that exception, you stop that function and return that exception, return that abrupt completion. By the way, that abstraction is called return if abrupt. So the question mark means return if abrupt. So if I had to call this .at with new as a this value, I would interrupt the execution of my function here. I wouldn't do any other of the further steps, and I would throw that exception, that abrupt completion. But as we don't have this abrupt completion, let's just go forward. As we return that value, for the first line, we can say, oh, it's basically going to be the same as this this value, which is the array. So on step 2, we have another abstraction, but length of array like. There's a lot of abstractions here, and length of array like is another similar step-by-step process where in the first line we have an assert line. That assert is just a notation in script saying this is not doing anything. This is basically asserting the object that length of array like is receiving is always the type of object. So it means that all the time ECMAScript calls this abstraction, it already sanitizes the value to make sure it's object. And in this case, it's an object. You need to get a lot of things from here. A lot of abstractions merged in this very same line. The first one of them is get abstraction. Is in general, I'm not going to jump too deep, but I'm going to tell you here, and you can believe me, get is extracting the value of the length property in the object that is given. So object would be my this value or the array, and the length of array is the size of elements the array has. So this value will be 4. And then I have another abstraction, which is a toLength. toLength will try to convert that value in a possible length of arrays. This is the best simplification that I can give for toLength in here, but also another abstraction just to make sure the value will be a number which represents a length of array-like objects. Saying that, as I mentioned, it was 4. And just to make sure we have room for this whole presentation, I can tell you in advance, length will be 4. And so now have another abstraction going for index. This is a 2 integer. Let's say you call .add, and here comes like one of the most interesting cases of specifying things, because in our example, we are pretty much using a very expected input for the .add, which is like calling it with 0 or -1. When you think about numbers, indexing numbers, it's pretty much easy to think about numbers that just work. Let's say a number is, instead of giving a number, you give a string, or you give an object. You need to make that number is coerced to a string, to a number, to an integer value, not only like floating point values or anything. You need to make sure you extract it to integer. So here I'm trying to define a new value. Relative index would be this integer representation of index. See, there's a question there because it also can break at some point. It can return an abrupt complete. In my case here, I know index is 0, and the integer representation of 0 is 0. I don't have anything to worry about in this first case. So relative index is 0. And then we have an if-else for my pseudocode of this specification. Once again, is just, relative index is greater than or equals 0. So we just go to if branch, and we can assume k will be 0 as well. And I can skip number 5. Number 6 as well. It only considers if k is not greater than 0, but also greater than or equals than length. We know k is 0. We know it doesn't go through line 6, so we know we go to more and more abstractions in number 7. So what I first showed as like just 7 steps of this method to work, we still have like so many abstractions underneath. So there are many steps underneath. And you see here, there's not a question mark, but there's a exclamation mark. And what that means? That means something similar to the question mark, but that means there's calling toString on the k value means toString could actually be an abrupt completion, could return an exception. But in this very case here, I am giving it to the implementer, people who are reading this specification, that toString in here will never return an abrupt exception. In this, toString might return an abrupt expression in other uses in the specification, but not here. So what we need is to convert k to a string. So once again, I have the value 0 converted to a string, which will be the string 0 inside. And I'm going to try to access toString from O. O is, once again, that array, and which is the first of this array. So that's a way to understand how the specs work. I know it's a lot of baby steps, but this is pretty important to do baby steps like this, to read the specification like this, because I just gave you what. But when we have many different inputs, we have like, as I mentioned, like regular indexing numbers when you have 0, 1, or negative numbers as -1. Or let's say you give not a number, what should happen? You go through the steps again and to understand like what should happen and at when it should happen. The order of things happening is very important for how we implement things. And to make sure if I have a failure in a browser, the same failure happens in the other browsers. That's important for communicating a message. You don't need to have different exits if you have a different browser. The platform is not a browser, the platform is the web. The other example here, I'm even given a full object that can be converted to a number, or let's say the example where we give a different this value. So there are many things to learn and discover from, and everything we go here like step by step. For the unfortunate shortness of 1 hour, which is it's already like a very fair and good time to give this presentation, but like for ECMAScript being so dense, I cannot stress that much longer, but I'd love to continue more of that, and I'm going to show more ideas. I want to jump to understanding the syntax. And if you, I hope you thought that API was somewhat easy, because now we deep dive into ECMAScript. Now that's going to be pretty. I'm going to give you like a code that might look simple, but I'm going to do some syntax analysis of it. And once again, let's do it step by step. If you read this code, you will assume what is happening here. You might assume what is happening here. You might know what is happening here. But we need to read that out as an implementation should. So what that means if we have this code. Okay, so when you read this code, and if you try to figure out, like, extract all the pieces from this, the first thing that you see is a var, which we can assume is a variable declaration, and we know it expects a byting list. And then we have x, which is a byting, the byting x, which expects initializer, comma, or semicolon. So we know what to expect right after this piece of code. And we have a comma. And the byting separator, just calling this here a byting separator. And what the byting separator, when you see it, what it does expect next when you're reading code. You expect the next byting. So you have the next binding, as this is a valid code, of course. You have the binding y, which the binding y once again expects initializer, comma, or semicolon, and we have an initializer, which expects a value. And yes, we have a value, which is an expression. After you have this expression, you can expect comma, because it can be a continuation of that expression, or you expect a semicolon or a line break, also considering automatic semicolon usage. Let's not go through that ship right now, but you expect the termination of that thing, or you might also expect not a continuation for the expression, I'm sorry, more bindings or anything, but we have a termination, we have a semicolon. It means the end of that declaration. And after that, we expect the next statement. We don't need to have a next statement, or that's the end of my code. This analysis is defined through a specific grammar. What I'm telling you here is not that I'm like making up things out of my mind. I am just reading and showing like how the specific should describe it. Once again, for a user, developer, it's so easy to say like, yeah, you're declaring X and Y is initialized with 1 million. But this, the ECMAScript does have the duty to describe that code and what that means. So for a variable statement JavaScript, you have you expect the token or the characters or var, and after var you have a variable declaration list, which is the whole list that you have here, and it's terminated by the semicolon. But I mentioned we have the declaration list. For the variable declaration list, I have more pieces, and just jumping a little bit ahead, you can see a variable declaration, which is formed by the binding identifier with an initializer. You see there is an optional part in there. That means the initializer is optional. You can feel free to skip for now the green parts of these characters, because that goes even deeper on how do you declare those productions. Trying to stick with what we have in front of us, yes, we do have in this case here just a binding identifier for X, and there will be more descriptions of what a binding identifier is. And try to connect this syntax description to our matching grammar of what we just mentioned on .at. You remember we had that example at. We know, like, if we call a method, it should run through those steps. But what it means for the language to understand this is an actual method call, function call, and how the engine know this is a function call. Much more for us, it's implicit that we know this is a function call, but we need to tell the machine to figure that out as well. So the same way that I described the variable statement, I can go here and tell you, and please bear with me, this is a call member expression, and formed by member expression and arguments. How do I know that? That goes through a very, very, very long this kind of definitions and expansions of my syntax. If you jump through script, you can go and find scripts formed by script body. Then we have a statement list. Statement list might be formed by list item, and then a statement, and the statement is formed by expression statement, and then by expression might have an assignment expression, conditional expression, sort circle expression, all the way until you finally get to call member expression, which is a production of the lovely named cover call expression and async error head. That's one of the funniest names in ECMAScript. And you can navigate through these productions in the ECMAScript grammar notation. But what it means to have this all there. So in this case here, we have a member expression. Member expression is formed by this array and until the dot at and the arguments part. The primary expression, which how we do understand how the member expression is formed. The member expression might be formed by another member expression, which is a recursive production. So one part of it can be a primary expression, which is the array literal, and the identifier name. You see there is a dot in the grammar notation, so dot and identifier name. And in my case, I continue this grammar notation saying this part is the arguments, which can be formed by simple parentheses, but also parentheses with the arguments list. And yes, there is still more in the arguments list that can be expressed. And you still have an assignment expression here, which can be so many things. But I can tell you in advance, the 0 is a valid assignment expression where I have a numeric literal. But so far, we just parsed the syntax. There's a lot of going deep through just to understand syntax notation and just identifying parts. But one of the first steps for the syntax is what we call the stat evaluation of the code. It's just like figuring out parts and labeling all the pieces you have in your syntax. But after you have that, you have a runtime evaluation. And ECMAScript comes in with a list of step-by-step rules of what should happen when you see that part of code. So there's 2 steps before you actually call that method .add. Those steps will run right before that and figure out like, yes, this is a method that should be called. And before we call that, we need to extract what it means to be that value of that array and store that value in memory. We have a method. Let's access this method. Let's see if that method exists. If it does exist, it's calling with that argument. And so let's call that function .add with that argument. And then we finally jump into the steps for the .add, specific steps for the .add. But this is like the general evaluation of a method when we have it called. And we have runtime evaluation for everything that we have in ECMAScript that you have available for all the execution. For the static rules as well, you have some exceptions to saying like, hey, we describe this production, but we currently forbid this production, and we say this production is an error right now, and etc., etc. There's a lot. It's a lot. And I'm just like going like with the very tip of the iceberg here. And in order to make sure we can keep track of this and make sure like things work consistently, we keep a comprehensive set of tests for more tiny bits, and to make sure every implementation works seamlessly. Once again, the goal for ECMAScript is interoperability. But interoperability, that's a hard word to say with my accent, so excuse me. For things to work nicely in every browser, you need also to verify those things are not only correct, but also the implementations are correct, and everything should be verified. Just assuming that there is that implementers will read to finally implement, then you need to make sure everything interpret that pseudo language of ECMAScript in the same way. So for that, we have Test262, where we put all the tests together for this ECMAScript suite. To give an overview of Test262, what it is today, this is a TC9-owned project that has more than 78,000 tests for beans and language syntax, many of them separated by almost 40,000 test files. And 62 is bundled in the main CI process of mainstream browsers and other projects. It is not only a fun project that is part of those projects, but it's also required step in the TC39 process in order to make things become part of the web. They need to present, the proposals need to present tests in 62 that are valid and show the implementations are actually passing that test. It's just not assuming or doing something superficial. It's going through every step that we mentioned there to say, yeah, this works as described in ECMAScript. And we have more than 15 projects that I can count today using Test262 directly as part of their test suite, like Babel, the browsers, every browser that you know is using Test262. And the funny part, every test is written in pure JavaScript. So basically the things that we mentioned there, like the step-by-step, we write a JavaScript to observe an input and output of the syntax or a built-in execution. And even better, Test262, due to TC39 rules, is an open source project, and it's royalty free. You can take Test262 and own a claim that is not yours or claim rights on it. That's pretty good. And today, this project is supported by Test262 Test262.report, with daily results of tests executing in some target engines. How is that important? One of the goals for standards, as I mentioned here, is interoperability. And the test brings that as their impact to the whole web development ecosystem. To give you an idea, when this project was released, and I'm glad that I was part of the creation of the project among some developers, the project was showing some results from the browsers, like JavaScript Core from WebKit Safari, SpiderMonkey from Firefox, or V8 from Google Chrome. They were all under 90% of passes each. That happens as well because Test262 is part of their CI, but most of them, and most people running Test262, it's so many tests and there's so many features that are not implemented yet. People just tend to get failing tests and put in a skip list, ignoring the test for long. With the Test262 reporting the results, we also created a pressure on the browsers because we are exposing breaking pieces, little pieces of that is not fully web compatible within those browsers. So we had some change coming in. 1 year ago, Test262 evolved from 68,000 tests to 72,000 tests. JavaScript had a small percentage fall, but actually it was not mean they were passing less tests. They were passing 2,000 more tests. We just had more features coming in. We had 4 new 1,000 tests, but they were still passing on to more 2,000 tests. Same with SpiderMonkey, but in this time now getting raising the percentage from 83 to 86. We were starting to show where they bleed, and they were starting to making sure they are doing good work, by the way, to make sure their browsers are more compatible, because it's also not only a goal for web developers, but it's a goal for them. It's a shared goal for everyone. And V8 was just starting something that was very nice. They went to 90%, but look at what we have today. and you can see those results in Test262 report. For today, we have 78,244 tests. JavaScript finally jumped to 87% with more 10,000 new tests passing. And that's because we added like almost 6,000 tests. So they are like overcoming any debt they had in the past. They basically have like 68,000 tests, where in 2 years ago they didn't have all of this number in tests. For SpiderMonkey, now it's 89%, and for V8, it's an incredible 8% of test passing. So that means V8 is like really getting there with being compatible with what ECMA is scripting, because we need to make sure the specification is there, but we need to make sure the implementations also do it as it's described. You don't want a surprise. Everything that is like not up to 100% might be a surprise to your end as a web developer. Surprises of browsers or differently. You want the browsers as described, as documented, because what you want is a documentation of how something should work. And you need to bring this power back to you. You can see more on Test262 report. There is not only limited to those engines, it's raising to more JavaScript engines and projects. There is Modable.js with also an amazing credit percentage. They have 99% of test passing in, for the syntax. Most of their percentage is not just too high because they don't implement Intel, which is optional for ECMAScript. That's actually a fun fact in here. Intel is optional. That's totally cool if it's not passing, but like some of them are bringing like amazing percentages and making the web more compatible today. That means identifying part feeds the test. We need to know how to identify parts of ECMAScript to feed our test. We need that whole process that I told you, the process that I personally do for writing down tests and figuring out what to test in Test262. And that ends up as helping moving the web forward and making sure the web works as a single platform for everyone. And just stealing a phrase that you might have known as always bet on JS, I would also say, but first verify it with Test262. You can still bet on JS. And spasibo. Thank you very much. And also in my own language, muito obrigado. It's been such an honor to be here and talk to you. Thank you.
Thank you, Leo. That was an amazing presentation. Thank you for all the insight and for sharing all your knowledge with us. One thing that really intrigued me in a way is that you showed us a lot of spec text. And we talked about DC39 as a big committee. I imagine all these proposals are coming in from really a very diverse group of individuals. People living all across the world and working for different employers, and they're all developing different features at the same time. So is there somebody who ensures that the different functions and their specifications are consistent in a way that they all fit to form a coherent whole? Is there an individual effort on part of every single author?
I'm not sure if I understand the question. Can you repeat that? I'm sorry, I got a little bit lost.
What I meant was that is there somebody who works on making everything consistent, or is it something that the authors do by themselves?
No, this is collective work. In order to make things working consistently, this is a shared effort, and it cannot be different. It's not owned by anyone. If we need to set like some ownership right now, it's basically TC39 has the ownership of test262 in order to making sure they do their own janitorial work for ECMAScript. Test262 is not but like a verification of the work done in ECMAScript, and it is, while the project is maintained by some people today. Rick Waldron is doing the maintenance of Test262, and but it's a lot of work in there. But it's a work that requires like champions of proposals coming in, also altering tests. If they are not altering, people need to review the tests, because it's not a work that can be done by a single person or just a subset of individuals. Like everyone that is committed to confectioning standards, making sure the standards work in that way, they also help providing inputs on how those things work. I have so many moments in my memory that I've had to, when I was writing tests for some proposals, and I had to go to the champion and say like, hey, is this really supposed to work like in this way? Most of the time they just confirmed that it was a yes. Some of the time that we found like some consistencies in the specification. But the ECMAScript is not a work that I feel in general to be done by any individual, but it's a collective work, and that also includes the work in Test262. So this verification to make things working consistently requires some work that comes from all. Also, you got like the browsers. They all have like different runners and different forms to execute Test262. Which is also fun. It's not a project that runs in a single way. Projects are in a different platform in different aspects. JavaScript is present not only like as in browsers or anything. Sometimes there are parsers, there are transpilers. Sometimes they're in a spaceship as they're using ECMAScript. So you have different ways to execute things that happens on Test262. So this work is also done by different people in different platforms on how we actually read and execute those tests.
Thanks.
I hope that answer resolves the question.
Okay, so I also have a question for you. So you mentioned that when like 2 years ago, I think it was, browsers had like low compliance with the specification. It was like 90%. And so there was like a mismatch in the real behavior and in the behavior of tests. And also before our talk, you told us that you got started contributing, and because there was some some inconsistency in the spec, and you brought this up to the committee. And does this still happen? So does it still happen that the tests do not match the spec or something like that? And what do implementation do in this case?
It happens more frequently than you can imagine, and even more frequently than I believe TC39 wants. But it happens by simple natural aspect. We're all humans, and we have different interpretations of ECMAScript and the concepts underneath the specification. So sometimes we try to design thing, and ECMAScript is really like, how do we want to say something should be implemented in a generical way. It's not like I'm not really implementing JavaScript in my machine. Actually writing some documentation step by step saying like this should run this way. Sometimes it's read differently by some people, like because we have so many step by parts of it, so that it's you can fragment ECMAScript in the most tiny bit parts. and those can happen differently. Like people create bugs, and it's fine. It's part of the process. That's why we have a process where we include tests to verify those things are a little bit more consistent. Sometimes we have inconsistency even on test 262. I happen where in the past I read something and I wrote the wrong test, and because the test was actually behaving different from ECMAScript itself, and because we had a test on that, I created a problem. I had some implementations that just followed the test instead of the specification. That's a problem with test 262. We need to make sure test 262 does not create rules, but it just like verifies the rules already on ECMAScript and does not create anything beyond the rules from ECMAScript. So I had some browsers implementing what was in test 262, not ECMAScript. So TC39 had to discuss a new direction, like what happened, and should we change the implementations or should we change the test or the specification? There are three parts in here that we need to be considering where should something be fixed. And the cause of this, there's no versioning of JavaScript in the JavaScript ecosystem. There is one JavaScript, the JavaScript you use every day. So JavaScript only evolves. You cannot switch back to a different version. It's the version that you have available. So if you implement something that is wrong, that thing might become a feature. We have so many things documented today in ECMAScript for things that we implemented in the past that had to become a feature. We have string prototype blink. You can still run blink from a string value to create the tag blink, wrapping up a string. And it's something that happened. It was implemented. It was not specified before, but it's specified today to make sure at least other browsers also implement the same thing in the same way.
Yeah, I think we're close to time. But thank you very much for your presentation. And I hope you had a good time. I hope everybody liked it. But Lexi, take away.
Oh, thank you so much.
Thank you.
It
Thank
was
you. I
really,
think, yeah, continue,
go ahead,
please.
sorry.
We have some delay. Yeah.
Oh no, sorry. It was just to mention it's such a great opportunity to be here, and I'm really grateful for being part of this. I hope I can actually see you in person, and the next time when we are over these tough times for everyone.
Okay, guys, thank you. It was amazing. And see you in discussion zone. And have a good time here. Bye bye.
All
Thank
right.
you.
Bye.
Bye.